Good evening, everybody. Uh, this video is the last video about the Flownet, and next we will go for the numerical problems. And in my Google Classroom, there will be a different numerical problem has been already uploaded. Please follow that. In previous video we discussed that the construction of Flownet, how to construct a Flownet. Now after the construction of the Flownet, our main purpose, in previous lectures I also told that our main purpose is to determine some parameter of the soil from the Flownet. At the first we discussed that determination of seepage from the Flownet concept. Determination of seepage from the Flownet concept, and the formula to determine the Flownet, that is Q equals to KH NF by ND. This is a formula to find out the seepage. K, you know that K is the coefficient of permeability, H is the head difference. Now I construct another diagram of the Flownet. This is a seed pile. This is a seed pile. Seed pile. Now head difference here is here head is water head is H1, and the downstream side the head is H2, and the flow line, because this is a seed pile, water can passes through this line, that's why it will passes through this pattern, and another flow line, and this is another flow line, and same the potential drop will be here, this one straight, this one and this one. Okay, this is our Flownet. Now here NF and ND. NF, that is flow line 1, 2, 3, 4. Okay, that's why NF is 4, and ND means the potential drop, that is 1, 2, 3, 4, 5, 6, 7, 8. That is 8, and put the value here, and you will get the quantity of seepage from the Flownet. Means now you can easily find out if anybody assign you a work that this is the dam and the soil strata, you consider some thickness, and then find out the seepage in the downstream side. You can easily find out the quantity of seepage in downstream side. Now our second application is to find out a hydrostatic force. Okay, another thing we want to discuss, that K we know that the coefficient of permeability, and the coefficient of permeability, in many cases there are two types of permeability, means in X direction and in Y direction, mainly in dam. Okay, at that case the K value you consider, that is root under Kx and Ky. Okay, root under Kx and Ky. Okay, if in 3-dimensional, then suppose Kx, Ky and Kz, then it will be 1/3. The K will be 1/3. Keep in your mind, if this is very important for your GATE or any competitive exam. If you check your previous GATE question, many problem on the basis of Flownet. Okay, That's why keep in your mind all things, keep in your mind, and you can easily solve that problem and easily secure at the marks. I think there will be 2 marks or 4 marks. Okay. Now our second is determination of hydrostatic pressure. Means from the Flownet we also determine the hydrostatic pressure. Okay, and the hydrostatic pressure Pu equals to HW into gamma W. Okay, Pu equals to HW into gamma W. This is the formula to find out the hydrostatic pressure. Okay, now suppose in this point P we need to find out the hydrostatic pressure from the Flownet. Gamma W, you all know that unit weight of water, and that is 1 gram per cc and 9.81 kilonewton per cube. Okay, then on HW means the piezometric head at that point. Piezometric head at that point means we find out P here, means that will be H1 minus 1, 2, 3, 4, means 4 into H1 minus H2 by ND, that is 8. Mean HW for this point is H1 is the head and NF, that is P means 1, 2, 3, 4, 4 into head difference by ND, that is HW, and put the value here and you can easily find out the hydrostatic pressure of any point. Okay, now suppose in this point then it will be 5, in this point it will be 6. Okay, now our third is determination of exit gradient. Okay, now you can say that sir, what is exit gradient? Good question. Exit gradient means at the downstream end when the water leaves the soil and it goes to the free water zone. मतलब डाउनस्ट्रीम साइड में जब वाटर सॉइल के अंदर से सीप होने के बाद सॉइल को छोड़ के फ्री सरफेस में स्टैक होगा, एट दैट ग्रेडियंट इज कॉल्ड द एग्जिट ग्रेडियंट, एंड द एग्जिट ग्रेडियंट IC equals to del H by A. What is A? A is the average least dimension of the square. मतलब इस ये फ्लोनेट में सबसे छोटा वाला स्क्वायर का जो एवरेज लीस्ट डायमेंशन है, लीस्ट लेंथ है, दैट इज ए. ओके, एंड अनदर थिंग्स इज that is E. And another gradient we know, that is critical hydraulic gradient, IC. This is a critical hydraulic gradient, that is IC, and IC equals to G minus 1 by 1 plus E. Okay, this is very important. All things are important. Okay, critical hydraulic gradient, this exit gradient and this is critical hydraulic gradient. Critical hydraulic gradient is equals to G minus 1 by 1 plus E. G minus 1 by 1 plus E. Okay, and seepage pressure, and the fourth one is seepage pressure, and that is PS equals to IE into gamma W. IE is the exit gradient and gamma W is the unit weight of the water. Then seepage pressure also we find out from the Flownet concept. Now another thing is piping. This term piping. If the exit gradient is greater than critical hydraulic gradient, if exit gradient is greater than critical hydraulic gradient, then at that case piping will be occurred. At that case piping will be occurred, and factor of safety is equals to IE by IC, and factor of safety is equals to IE by IC, means exit gradient by critical hydraulic gradient. Okay, now we covered Flownet. Okay, I uploaded all videos, notes. If any question or any doubt, please ask me. And next we will discuss some numerical problem, numerical thoughts on this Flownet concept. Okay, thank you.